Hello again, physics people. I sure hope you're having a wonderful day. Today, we're going to talk about trying to solve projectile problems. How do you solve a problem when things are flying through the air? We're going to do a lot of these, so this is kind of an important one here. First thing, from last time, remember the across motion and the up and down motion are totally separate. All right. Remember also, gravity is only changing the up and down motion, the vertical motion. Okay, gravity is only pulling something down. All right, it doesn't change what goes across. So it'd be good to write those things down again to get them into your head. What do we know? What does that tell us? First thing it tells us is that we should divide up the vertical and the horizontal motion. So on your paper, divide it down the middle. We're going to talk about what's vertical and what's horizontal. All right, I missed the middle of my screen here by a little bit, so sorry about that. All righty, so a couple things. Let's think about this. If we make up positive, okay, and when you're doing an AP problem, here's what you can do. Just somewhere on your paper, you can put a big arrow and you can write positive. So I'm going to do it in two places just so we don't forget. Positive is up. If that's the case, then the acceleration, A, is going to be negative g because it's down. Okay? And that's obviously in the up and down direction. In the across direction, there's no acceleration. A equals 0. All right, let me slide this down a little bit. Let's go quite that far so we can remember what direction's what. The other thing we know, the initial velocity in the up and down direction isn't really just v0. It's v0 in the y direction. We're going to take y to be up and down. Then in the across direction, v0, we can't use v0 anymore. We have to use v0 in the x direction because we've divided up things. Next one. Our regular v isn't just a regular v. It's v in the y direction. Same with x. V in the x direction. Okay? One more thing. This one's a little tricky. Actually, two more things. The other thing we're going to do is we're going to try to remember to change all the x's to y's in the up and down direction. So we're just going to change x to y, and all that means is the distance in the up and down direction. Okay, y is usually on the y-axis, up and down, from math class. So we're going to do that. The x's we'll still call x's, okay, in the across direction. Now, those are the differences. There's one more thing that's really important. The time in the up and down direction is the same as the time in the crossways direction. That's our connection from the across to the up and down and back and forth. Up and down time is the same as the up and down time. Across time, sorry, I didn't say that well. The time in the across direction is the same as the time in the up and down direction. So, what does that look like? Let's go to our equations. What I'd like you to do now is draw a big line, and we're moving on to equations. Write down the first equation in the vertical column and in the horizontal column. What I want you to do then is say, what does that become when we transform it just alone into vertical and horizontal? So, for example, change the v. That is, let me just show you exactly where I am. This v right here is going to change to v in the y direction. So you're going to have to go back and forth. When you get it done, go ahead and pause me. Actually, pause me. Then when you get it done, start me up again. Okay? Alrighty, here's what I got. In the up and down direction, our first equations become these. Notice what I did. Over here in the x side, the horizontal side, a times t, well, if a is 0, that whole thing goes away. right? We get to make that 0, and I didn't even write it down. I just left it out. So check this out. This is kind of crazy. This equation over here actually is a little bit silly. It says the velocity at any time in the x direction equals the initial velocity in the x direction. Well, think about it. We knew that. It's not speeding up or slowing down. There's nothing pushing on it. So, of course, the velocity at the beginning is the same as the velocity at the end. All right, in the x direction. So, think about that for just a second before we move on. That equation doesn't really help us much. Helps us a little bit. Alrighty, let's move on. Next equation. Let's go to our second equation. Go ahead and write it down in the vertical and horizontal columns, and then see if you can make the changes again. Pause me, and when you're done, I want you to go ahead and start it up again. Here's what I got. How did you do? Notice what I did. Plugged in negative g again at for a in the vertical side, and that whole last term on the horizontal side, the 1/2 at squared, I just got rid of because a is 0. Okay? How'd we do? Did you do all right? All right, you guessed it. Let's move on to the third one. See if you can do this one by yourself, and then go ahead and start me up again when you're done. All righty, here I go. That's what I got. Notice what I did over here on the left or right hand side, and I just found a mistake. I got to erase the square. The equation I ended up with is that one. V squared in the x direction is the initial v squared in the x direction. Well, I just took the square root of both sides, and I end up with the same equation I ended up with the first one from the first equation for the x direction. Alrighty. So you're going, what the heck? How does that help me? Well, let's move on. Whoops, I'm sorry. I jumped back to the second equation. My fingers are not working here. There's where we just were. Alrighty. So here's what you're going to do. Somebody will launch something, a cat, out of a cannon, just as an example, and they're going to give you an initial velocity, v0, and an angle. You're going to use your sine and cosine tricks that we learned, and you're going to come up with v0 in the y direction and v0 in the x direction. Then I want you to get ready to attack the problem. Okay? So, here are some good things to do. Draw a picture. Okay, divide up the paper so that you have space to work up and down direction and a crossways direction, vertical and horizontal. Draw a line between them. Tell the grader what you're doing. All right? So imagine someone's grading this as an AP exam. You got to show them what you're doing. No, oh, I put 3 before 2. And oh my goodness, this is terrible. I am just awful today. There's 2. There's 3. And there's 4. Man, I am just an awful teacher. I apologize. Somebody can slap me silly tomorrow. All right. Number 3. Write down what you know, all the things that are given to you. Now be sure to put them in the vertical or the horizontal spots. Okay? And then here's the key, number 4. Remember, time is the same for both directions. So a lot of times, a whole lot of times, you're going to solve for time and then transfer that time over to the other direction. So you'll solve for something in the up and down direction, take that time and put it over in the vertical direction. Okay? Or in the horizontal, I'm sorry. Boy, I just can't type. I can't talk today. Nothing's going well. And so anyway, after you do number 4, which is remember time is the same, you just look and see what you can solve for. Sometimes it's a 2 or 3 step problem, and you might have to solve for something in the middle to get where you want to go. All righty. Oh, I apologize. I hope you made it through that lecture. I'm just kind of out of control today. So here's your problem. Hope you enjoyed. It's an extension from last time's problem. And that'll be it. We'll talk to you soon. Have a wonderful evening. Bye-bye.